Guys, so let's talk about Kubernetes label and selectors. So labels are basically key value pairs which are attached to pods, replication controller and services. They are used as identifying attributes for objects such as pods and replication controller. They can be added to an object at a creation time and can be added or modified at the runtime. Now coming on to selectors. Labels do not provide uniqueness. In general, we can say many objects can carry the same labels. So label selectors are core grouping primitive in Kubernetes. They are used by the users to select a set of objects. So Kubernetes API currently support two type of selectors. One, equality based selectors, and two, set based selectors. Now equality based selector, they allow filtering by key and value. Matching objects should satisfy at the specified labels. Set based selectors allow filtering of keys according to a set of values. Now in the code which you can see on the screen here and pointing it through my cursor, we are using the label selector as app column sales platform and component as component column any neo4j. Now once we run the file using the kubectl command, it will create a service with the name sp neo4j standalone, which will communicate on port 7474. The YPE is node port with the new label selector as app column sales platform and component neo4j. Now let's quickly move to Kubernetes namespace. Let me flip my okay. So namespace provides an additional qualification to a resource name. This is helpful when multiple teams are using the same cluster and there is a potential of name collision. It can be as a virtual wall between multiple clusters. So functionality of namespace. Following are some of the important functionalities of a namespace in Kubernetes. Number one, namespaces help pod-to-pod communication using the same namespace. Number two, namespaces are virtual clusters that can sit on top of the same physical cluster. Number three, they provide logical separation between the teams and their environments. Now, creating a namespace. The following command is used to create a namespace, which you can see at the top. Now, control the namespace. The following command is used to control the namespace. This is to control the namespace. In the above code, we are using the command to create a namespace. This will list all the available namespace. This will get a particular namespace whose name is specified in the command. This will describe the complete details about the service, and finally this will delete a particular namespace present in the cluster. Now using namespace in service example, right? So following is an example of a simple file for using namespace in service, and you can see it here. The code is written here. Okay, in the above code, we are using the same namespace under service metadata with the name of ELK. Okay, now let's quickly move to the next portion of the same, which is Kubernetes nodes. Now, a node is nothing but a working machine in Kubernetes cluster, which is also known as minion. They are working units which can be physical VM or a cloud instance. Each node has all the required configuration required to run a pod on it, such as the proxy service and kubelet service, along with the Docker, which is used to run the Docker container on the pod created on the node. They are not created by Kubernetes, but they are created externally either by the cloud service provider or the Kubernetes cluster manager on physical or VM machines. Now, the key component of Kubernetes to handle multiple nodes is the controller, which runs multiple kind of controllers to manage nodes. To manage nodes, Kubernetes creates an object of kind node which will validate that the object which is created is a valid node. Moving on to service with selector. As you can see at the top, in JSON format, the actual object is created which looks as follows, as you can see here. Now, node controller, they are the collection of services which run in the Kubernetes master and continuously monitor the node in the cluster on the basis of metadata.name. If all the required services are running, then the node is validated and a newly created pod will be assigned to that node by the controller. If it is not valid, then the master will not assign any pod to it and will wait until it becomes valid. So Kubernetes master registers the node automatically if register-node flag is true, as you can see here. However, if the cluster administrator wants wants to manage it manually, then it could be done by turning the flag off, as you can see here. So basically this completes the details on nodes as well. With this we are just taking a pause, and in the next lecture we would be covering a few more. Till then, thank you very much.